Alrighty, let's start this a little earlier than I scheduled it in. But this is a little ad hoc stream that I'm doing. I'm having a look at Colins Drawable Textures PR. Just compiled Godot from his branch so that I've got the logic. I've been talking to Colin for a little while about this and helping him out and stuff. And I've been wanting to try something using this for a little while. And of course, in my usual style, I'm going to do something way overkill. So we're going to be doing a little bit of setup before we even get to trying out the drawable textures. And maybe I'll do all the setup for nothing. We will see. But yeah, that's the plan for today. So I've already set up a little test scene just as a start. All that we have here is a very simple 3D scene with our world environment and a light in there so that we can see around. Friends, I actually still don't know how to pronounce his handle, but I'm calling it Friends, FR3NKD. Little pushy model. We're going to use that and have some fun with that. And then, of course, I got a camera so that when we run this, of course, it runs in the wrong place. We can see our plushie, and there we go. Hey, Sirkin, how are you going? So yeah, so the first thing that we need to do is a little bit of setup that has nothing to do with the drawable textures. And the first is a little bit of camera control. So I want to be able to do something similar to this, where we can move around. But instead of the middle button, I'm going to be using the right mouse button for that, and doing something similar where we can just go there, and then left to right. And I think a good place to put that is actually on the camera. So I already created a script, just didn't implement anything, and we're going to handle almost everything in unhandled input. So let's first check if our event is a input event mouse motion. So that's how we know that our mouse has been moved. And then obviously we need to know that, let's see, does it actually autocomplete at this point? If it might actually be. Yeah, there we go. So, button mask. I always forget the notation for this. No, that's an and. How do you do that in? Because I want that to be right. Oh, haha. Button mask, and then this is going to be. Where is that coming from? Oh, that is actually already. And we actually mask right. Is that we have? Yeah, we got mask right. How do you check mask in Godot? That's a good one. I normally do this in C++, but I'm not quite sure what the yeah, it should be and, shouldn't it? Huh. I think it should just be a single and. And then obviously, yeah. I think that's what it should be. Yeah, and field. Ah, okay. Do that 100 times a day in C++. Never did that in GDScript in all these years. So we're just checking if our right button is pressed. And if so, then we are going to do some rotation work. I'm going to create some helper variables for that. That will be around the X, I think. There we go. And that also means I want to know the... Oh yeah, of course, warnings, because that is not going to do anything. All right, so we are simply going to say Let's start this with the y. Event dot relative. Should I do screen relative or normal? No, I'm just going to do normal relative. So the y is rotating around. So interesting enough, we are going to do rotate x. And we really need to do that with some sort of constant. Rotate. Actually, is it? It is. Rotate y speed. I don't know. I'm actually just going to do it like this for now. We'll tweak it when we figure out whether that works. So now we can create a rotation matrix from that. And we're going to send that actually, no, we're going to send that on our parent bases, because we want to rotate that guy so that the camera rotates around it, because we want to do an orbit. Okay, so that's going to be bases dot. Really? Oh, okay. Vector. No, 3 up. And then rotate y. Oh, that needs to have an equal sign. Really? So we try vertex up. Is that it? What the heck? No, it is vector. Oh. Oh. Okay, so ignore that warning for now, because we're just doing the rotation around the y. So if I've done that correctly, which I probably haven't, yeah, we can rotate. It's just that our rotation speed is meh. Okay, so that probably should then be something like this. Is that good enough? And it's the wrong way around. I think I also want to go and do a modulus on that. So let's go and instead do minus that. And then, oh, it's fmod, okay. And that needs to be fmod tau, so that we don't have that coming really high values. But now I can move that around. I actually wanted to move even slower than that. It's way too fast. So let's do a 0.2. That's probably too slow. That's all right. So now we can move our little guy around. Cool. All righty. All right. So now we want to do something similar, but with our x. In this case, it's a relative y, which is so weird. We're going to do a rotate x speed. We're going to assume that that's going to be the same. But this one, we actually don't do fmod. This one, we're going to clamp. I think we're going to clamp that by minus pi and plus pi, so that we can look all the way down and look all the way up, but no further. Now, this one we need to do before this. So I think we can do, whoops, come on, stop doing this. We can times that onto the y, and that needs to be left. Could be that we need to do right, but we'll see. All right, let's see if that works. So we still can move, look at that. We can move up. Okay, so pi, we need to do half pi. All right. All right, let's try again. Yeah, that's pretty good. I like that. we can move around. Alrighty, so now I just want to be able to zoom in and out. And for that, DD scripts, detect scroll wheel. I've never actually used a scroll wheel like this, so that is actually... Oh, that's like a button. All right, cool. So, else if, no, it's actually one deeper. Let's go and blow this up a bit because it's hard to see. Else if event is input event mouse button. And here we're going to say if event button index is button wheel up, and an else if down, I guess. All right, so cool. So the nice thing here is the easiest way to do the zoom in, zoom out is to move our camera. And because we're rotating on this pivot, our camera is in local space and we'll have a Z value that we can manipulate. So let's do move Z speed. Just set it as 1 for now. And if we scroll up, we want to zoom in. So what we're going to do here is position dot Z is position plus hold on. Do we just add the speed? So I think we're going to get this for every tick. So yeah, let's just do plus move speed. And then we're going to clamp this. We don't want to go... Oh yeah, this is going to be... because we're going to Z in a negative direction here. So let's say that we are going to do furthest is 100 and nearest, let's just say that we don't want to get closer than 0.1. And that does mean that this is way too big. So we're just going to say move speed is 001. So why is this one colored differently than that one? I don't know. All right, so we should be able to zoom in, but not zoom out. Yay. Oh, that is very close. All right. Anyway, that's okay. We can tweak that, but let's first make sure that we can also zoom out again. Oh, that's why, because that needs to be negative -1, negative -1. There we go. Alrighty. Hey, Doc, I am creating a little little test application right now. I'm just doing some framework and making it so that that we have this little push that we can orbit around and that we can zoom into and zoom out of. I need to put those zoom in and zoom out maximum values probably. Because I want to start playing around with drawable textures, and what we're going to be doing is we're going to be using drawable textures to actually draw on our plushie. Or that is the attempt that we're going to do. It might completely fail. We will see. And Jack, no, I do not stream on Twitch at the moment. I purely stream on YouTube. I did used to stream a little bit of gaming on Twitch, but I just never really got into it. Okie dokie. So, I just want to go and set that up as const min z is going to be 0.1, and that was actually too close. So let's make that 0.15, and then const max z is Actually, that was way too far. Making the texture file should be um, pretty straightforward by just saving it to a JPEG or PNG. That's just all built into Godot. So yeah, we might do something for that. Just to see if we can get that far. I don't even know if this is going to work. I'm obviously going to keep it very simple. But yeah, because it's, that's the whole thing of drawable textures, is that we do end up with textures from which we can grab an image, and then we should be able to save the image. So good. Jack, thanks for that. Yeah, I'm glad you're enjoying it so far. I'm mostly focused on XR work today. I'm just happening to do something, just something crazy, just to test out someone's work. There's this new feature called Drawable Textures. Oh, yeah, that works pretty well. And then actually zoom in a bit like this too. Actually, whoop, think. All right, cool. Zoom in, zoom out. Yeah, that's good enough for now. This is such a cool model. We're gonna ruin this model, but we will see what we can do with that. All righty. So yeah, for those who haven't seen it, let's see if I can quickly bring it up. So there's this this PR by Colin called Drawable Textures. This is hopefully something that will be added to 4.6 if everything goes right. And it's this new API that lets you do some very simple manipulation on textures. Instead of going through the whole rendering engine and doing complex things, and the thing that I'm about to build has been done before, but then with viewports, and this is just a lot more lightweight to do this sort of thing. So we are going to have some fun with that and see how far we can get. It's also the first time for me to actually test this out, so I have no idea how well it works. So I have bot scene created, and I want to spawn 1,000 of them. How would I do that? Oh, that is a very broad topic. It depends a little bit on what your bots do and how your bots work. So obviously spawning them in the simplest form is just adding nodes for each spawn and then controlling them. But the more of those you get, the more overhead you get and the slower things become. But if you want to have each bot move individually from the other, you might not be able to do it any other way. Again, it depends really on what sort of game you're making. However, if you are in a situation where you really need to draw lots and lots and lots of bots, then you start using Godot's instancing system, where it can draw a whole bunch of the same entities all at once. But yeah, that is a topic that is a little bit too far to get into in just right now. GD Quest, if you haven't found his YouTube channel yet, he has a couple of really good videos on that. He's got like a really good video on like bullet hell type games where you're drawing tens of thousands of bullets on the screen and stuff like that. So he's got some good videos on that topic. I personally do a lot in 3D. I don't use the 2D engine that much. So in 3D, obviously, it will be a multi-mesh, and you would just keep a table of where all the individual things are positioned. There's now even a way to do that on the GPU, which is really cool. I still need to test that one out. I haven't played around it with myself because it's pretty new. But that allows you to do it very easily in 3D. In 2D, as far as I know, there is a lot of automatic batching in the 2D engine, or the 2D part of the engine. But I'm not the best person to ask about that. So that's probably a good place to talk to or to look at GD Quest's channel. He does a lot of that sort of stuff. Conway's Game of Life be possible as a GD shader? I remember seeing something like that the other day that someone made. Yeah, actually, if you Google for it, I just found a link of that on. Is this for Godot or is this something else? This might be for a different. No, it's Godot engine. So, Duck, try and have a look at that. That is your Conway game of life as a shader. Okay. So, I think the first thing that we need to do is start setting up our new material here. So I've gone on our plush, I've just gone to editable children so that they can actually get to the mesh. And we're going to create a new ORM material here. And the ORM material gives us an albedo texture and an ORM texture. And we're also going to be using the normal map. And we're going to have a texture in that. So now, right now, our plushie is all white. Poor plushie. So the idea here is that we're going to start writing to those textures. And obviously we need to create a new texture for that. So why is that empty? Why can I not set that? That's interesting. Why can't I set the... Does it not like it because... It can't be set... Oh. Haha. Why does it not do that? Make ink. Oh. So, there we go. Now I can edit it. So for some reason, because I added in there, it thought that was part of the scene, but I'm doing it as an overrided material, guys. Anyway. Albedo. So what we want to do here is we should be able to create a drawable texture. Aha. Oh, and it starts as pink because we don't actually have content in it right now. So I think by standard, our drawable texture doesn't actually have any code in there, or sorry, any image in there. So we're going to need to set that up. We'll deal with that in a second. So we're going to do the same for normal map, and we're going to do the same for ORM. We're going to start just with the albedo texture. So for now, I'm also going to leave the normal map off, just to get a start with this logic. Hey, Lima, how are you going? Okay. So let's go and make sure that we at least have a texture in here, even if it's just blank. So we're going to go and create a script on our main scene. And we're going to make a ready function here. Pass for now. And we also want to do an onReady var. And for that, we're going to do albedo material drawable. Oh, no, actually albedo texture. Drawable texture 2D. Yeah, I'm excited. Of course, I'm doing something really dumb with it, and I'm probably going to spend half the afternoon trying to get it to work. But it is a really cool little little feature. We're probably going to need to make that a little bit better. Hold on. I'm just actually going to do that here and say material ORM material is material override so that I can at least get some help with that. Albedo texture. There we go. All right. So now we have that, and we can do some. Oh, I can't type, can I? Albedo texture. There we go. All right. So now the first thing that we need to do in code is actually set up our albedo texture, which we do with the texture drawable create. And we can set our sizes and our type, and then whether we're doing it with mipmaps. So I'm going to leave the mipmaps alone for now, even though that would normally make sense in this case. Albedo texture. Is that then? Is it a function? Yeah, I think that's a function on here. Texture. Okay, let's go and do this. Setup. Of course, here it's called setup. Let's go and make an export var for our width. Actually, let's make that size. Call that a vector 2. Vector 2. And let's actually make that a vector 2i because it's an integer. There we go. And with that, we can say size.x, size.y. And that can be an RGB 8 sRGB. That should mean that we're automatically converting to sRGB, which is really cool. And we're just going to make bitmaps false for now. Cool. All right, sweet. Okay. Oh, Colin lives near you, Lima. That's pretty cool. Well, next time you see him, tell him I said hi. All right, let's see if our... So yeah, now we actually have a white plushie again, because the default texture that is created here is going to be a white texture. All righty. Cool. Okay. So, the next thing, and this is the bit that's the tricky one, and the thing that I've never done is what we now want to do is that when I click with my left mouse, I want to be able to draw on this. And seeing our texture that we're using here is a drawable texture, we should be able to draw some stuff on this. Now, I'm going to keep it really simple at this point in time. So I'm not going to worry about seams. I'm not going to worry about orientation. So we'll see how that goes. And we'll do some funky things with coordinates and stuff like that. But it'll work for what we want it to do. However, figuring out where on the plushie we are drawing is a bit of a challenge. Now, when we look at a mesh, we have this thing called generate triangle mesh. And on triangle mesh, we have this thing where we can do an array to figure out where we're hitting. The problem is we're only getting position, normal, and face index back. We're not actually getting UV coordinates back for where we're clicking. And in order to get UV coordinates, we need a little bit more information that we're not getting when we're building our triangle meshes in this way. So we're going to make our own version of that logic by calling, where are you? There is a service get arrays that gets us all the data for a mesh. Now, this is where Godot is a little bit weird. Godot is meant to be a game engine and is trying to be efficient with its use. So really is one directional. You load in a mesh, you push it up to the GPU, and now it lives on the GPU. When we want to read back, we're actually getting that information back out of the GPU, putting it back into these arrays, and then working with this. So what I'm about to do is very inefficient, but we're just building a toy, so we don't care. All right, so we need that. So here, let's go and say set up our materials, and obviously we're going to have more in a minute. Set up our mesh data. So this is going to stall our application a little bit because I'm not going to be bothered by running this on a separate thread and doing all that sort of stuff. Just going to keep it nice and simple. All right, so for this, we need to go again. Actually, I think I do want to get an unready var. Actually, this no longer needs to be an unready var. But here we're going to say plushie mesh. Mesh is actually, that's going to be mesh instance 3D. And let's just call that flow sheet, and let's not call that flow sheet mesh. And that means that I should be able to do this. And that also means that I should be able to do this. Surface arrays. That is surface. Come on, learn to type, Baz. All right, there we go. Okay. Now that should autocomplete. So we're just going to get the first service array. We're not going to be worried about getting multiples. Why do I have a? Oh, because I am still working on that. You don't have to warn me that quickly. Service array is that. So now we have our arrays. And now we're going to go through our faces. So F in. No, I need to do that differently. Let me think. Why is that not autocompleting? She is because that is dot mesh dot. Thank you, Bass. I was wondering why that wasn't autocompleting. So yeah, we have all these things in there. Let's go back to add because that actually describes what we have. So that's going to be like that. Okay, let's hope that I get that in a usable fashion. So face count is going to be surface mesh dot array index divided by 3 because we have 3 indexes per face. Hooray! And now we can say face in range face count. Not sure if the range is still needed. I think there's a shortcut for that. Old habits die young, or whatever the expression is. Or old habits never die. Okay, so we actually need to set up a couple of things here. So we're going to go and get 2 arrays. Let's see. Get faces. So we have UVs. Facts, and that's a vector 2 array. And we have faces. That's going to be vector 3 array. Okay. Let's go and make sure that that is already sized correctly. We probably should get that without the doesn't really matter. So okay, wondering if I should just make this. Yeah, let's just go for this index count dunk, because actually I don't need to do it like that. I just realized that it's already set like that, so we can just do it like that, and then we can say no. Next is oh. Yeah, that wasn't very smart. Let's go and say our indices array. That's actually a packed. I think it's a packed 32 array. We'll see if that is indeed correct. And then this needs to be size. Then we resize those to that, and now it starts to make sense what we're doing. So, and with that, we should be able to say UVs vertex. No, this is going to be let's go and do that as well. So here we go and get vertices is array vertex and fix UVs. Right, and that's actually wrong now. Vector 2 array. Oops. And that is text UV. So let's go and get that vector 2 array. So we're just basically flattening out our mesh information into these two lists. So this is text UVs, vertex, index, and we're going to go get faces is vertices. There we go. So in theory, that should build the information that we need. I hope. We will see. And in theory, this is what that get faces should already do, but you know, it is what it is. So now we actually need to create a triangle mesh from this. We actually have a create from faces. Is that a static function? No, it's just a normal one. So we're just going to go and make our triangle mesh is a triangle mesh. There we go. And here we're just going to say create from faces. And that then becomes faces. And that should create our triangle mesh so that we can actually query it. This case, I guess we can remove our faces. We don't need to have that here. We can just leave that one here. But we want to have our UVs over here because with this, we can now query our information and then we can use that to look up our UVs. So now we need to make sure that we're going to do that. Now in our camera, we're not marking our camera as handled, which I guess we could do over here, but I don't care. So I should be able to do another func unhandled input. And here we're going to start checking for our left. All right, so wink, events, input mouse motion. In this case, we're going to check if our left mouse is pressed. And now we're going to go and get our the ray from our camera to our plushie. So one thing that's important is I have moved my plushie down, which we need to keep in mind because our triangle mesh data doesn't notice. So I'm going to shoot a ray from my camera onto the plushie, and I'm going to figure out where that hits our plushie, our mesh. But I obviously need to make sure that I take that offset into account. And that means that we're going to get our ray origin in world space, and we're going to get our ray direction in world space, and we need to adjust that. Now, we haven't rotated our plushie, so that is something that we can abuse here and not worry about, and simply worry about the offset. But we'll see what makes sense there. So in our unhandled input, we are going to have to do that part. Before we do anything else for that, that means that I want to grab my camera. That can also be an on-ready var camera. Camera 3D is come on. Here we go. Oh, make it nice and easy to get there. So here we should have a ray origin and a ray normal based on our screen point. And we're going to start using those. What's the difference with ray local normal? Returns a normal vector from the screen point location directed along the camera. Yeah, what's the difference between this? Return a normal vector in world space. Yeah, that's the thing that I need. Projecting the point on the viewport rectangle by the inverse camera projection. Yeah, that is what we need. So we need to get our project ray normal, and we need to get our project ray origin. Cool. So ray origin is going to be camera dot get ray. Of course, I already forgot what it's called. Project ray. Very good class. Project ray origin, and we need our screen point. So that should be in our event. And as far as I know, should just be able to use position, I think. Okay, let's do the same for our ray normal. Event dot position. All right. So now we need that in the local space of our push. So plushy dot global transform dot inverse, I think. And then we can do ray origin is in transform times ray origin, and ray normal is in transform dot basis times ray normal. And that shouldn't do anything because we're not rotated, and that should apply the offset of our plushie so that we have that in local space for our plushie. Yeah, Gaussian splatter. Oh, you found one in Godot. That would be cool because I've been wanting to try that out for a little while. I've only seen implementations in Unity, so really would like to have a go at making that work in Godot someday. All right, so we have a ray origin, we have a ray normal, and with that we should be able to do a ray intersect from there in that direction. So bar intersects triangle dot intersect ray origin, ray normal. All right, and I'm just going to go and print our various bits of information there. So this is supposed to give us a position, normal, and face index. Dot position intersects dot normal and intersects face index. Put some markers in between. And all right, let's see if we actually get not declared inter. Why is that? Oh, aha. Don't know how I managed to type that in wrong. All right. Oh, why is... Oh, create faces on a null value. Why is that? What's there? Rig games and experiences for education and marketing with Godot, MetaQuest. Thanks for your channel. Greetings back. Great to hear that. It's always fun to hear more people doing stuff with MetaQuests, especially in the education side of life. Okay, so what are we doing with this? So we're getting create from faces. Oh, so I need to make... Oh, hold on. I get it. No. I need to instance that one. Oh, why does it still think that it's running? That's interesting. There we go. Now, well, we are getting info. Okay, and obviously we need to do an if not is empty, because we might miss. Okay. Anyway, we had a lot of output there. So there we go. We get a position, we get a normal, and we get an index. All right, cool. And that is why we do need the faces, because that's the only way that we are going to figure out where the heck we are. Because we're going to need to get an XY. Oh, that's actually a really good one. Because we need to figure out where we are on that. What are you doing, Puss? Hey. No, Puss. I wonder if you can cheat on that. Probably can. Cat, what are you doing? What are you doing, Cat? What are you doing? That's a good one. No. Long live Google. Okay. That seems to be what we're after. So, interpolation in the 3D triangle is relatively easy. For any given point inside a triangle, we can find the 3 interpolation factors that work as weights. We multiply the values associating the weights. That makes perfect sense. Where UVA are that interpolation called the arithmetic coordinates of the point can be calculated according to drawing the below. So that's exactly what we want. So we have that position. We know these 3 positions, and we need to go and calculate some weights there. All right. Area and factors order. Okay, so let's just copy this over because that is exactly what we need. And I am not going to try and figure out exactly what that does, although it makes sense to me from the diagram. All right. Cat, what are you all on about? Why are you trying to get my attention? Eh? What is it you want? Hello. You hear me talking, you think I want some attention too. Eh? You want some attention too. All right. Yeah, the only thing with Gaussian splats is that it does require quite a bit of data, but you know, yeah, it is cool. All right, so from our face number, we just need to multiply that by 3 and we get our first face. And then we're going to calculate P1 as faces index, and then pick 2, 3, +1, +2. All right. And this should actually, you know what? We need F. That is actually our intersection point position. Let's just make a copy of that just so that it's easier to type. There we go. All right. Oops. Hey. There we go. All right. So do we have a magnitude function? We'll see. Actually, let's go and type this. I like to type everything. Okay. Says we don't understand that. Boink. All right. Can't find member cross of vector 3. Yeah, that's because we actually do that differently. So we grab this one, and then we cross that with that. Okay, and now in vector 3, do we not have a magnitude? What? How is the magnitude calculated? Vector. Oh, it's just length. Okay. That is just the length. Also, we don't need the semicolons. This is GD script gone. All right. Just going to go and do that. All right. So now we need to rewrite the other things. Hold on. Helps if I spell it right. All right. So let's go and change these over as well. So that's just going to be F2 cross F3 divided by A. And this is going to be F3 crossed with F1. Oops. Length divided by A. And then here, F1 cross F2 length. So yeah, that's how we calculate all the weights. There we go. And now we can go and get our vector 2 here. And obviously we need to have the right UVs. So that is UVs index. UVs index. Come on. Index +1. And then UVs index +2. There we go. That should be our 3 UVs. Yay! All right, let's just print that out and see if that gives us values that look even remotely like what we expect. But in theory, we should now get, well, they're between 0 and 1, so I guess that's good. All righty. Cool. So now we're going to use that to draw something on our drawable texture. Now, by default, what are we doing? Let's go have a look at our drawable texture thing. So normally we do a texture drawable blit rect, or yep, that's the one that we implemented here. So we are drawing to this texture. These are input textures, if I remember correctly. Why is my thing not working again? So it's not there. So these are the additional textures. That's what we're eventually going to handle. We do want a material because that's how we know what we're drawing. Although we can do something first with that as a rectangle. That is where we end up drawing on screen. And that's something that I'm wondering about, whether it makes sense to limit the rectangle or whether we need to do something else with that. Because when we limit the rectangle, we still get a UV from 0 to 1 within that rectangle. Although I have my GL position or my screen position for that as well. So I think I can deal with that. Yeah, because I kind of want to have a screen UV there. That's a good one. When we look at Colins... Ah, come on, computer. Don't do this to me. There we go. When we look at Colins implementation... Oh, actually, that's not what I'm looking for. I am looking for this. And what I'm looking for right now is looking at our... here, no, that's just hints. This one, inlet sources, No, it should be in the actual, this one. Nope. Those are different ones. Renames time, pi, tau, e. Oh, we got a frag coordinate. That should probably be good enough for what we need. That's actually a good one. Yeah, so the UV is normal, and here we have offset. That's the GL position, 1, 1. And I think that's also going to be our frag coordinate. So I think that is going to be directly where we want it to be. Yeah, I think that should be good. Just hope that it doesn't do some flipperoo sort of thing, which it's very good at doing. We'll see. So the next thing, we are going to get a export variable just to make our lives easy. And that's going to become our material. Actually, let's call that our draw material. And what we're going to do here is we are going to say, what's the type for this? Material. Here we go. I think that's a blip material that we're using here. Okay, cool. Something that we're going to do here is if we don't have a draw material, we're not even going to check our input. There's no point because we're now going to go and draw here. Oh, itchy. Okay. So I actually want to create a small rectangle around that. So our UV goes from 0 to 1. So let's go. What is our drawable texture again? albedo texture, that's going to be our main texture that we draw to. We're going to say blit rect. Yeah, I know, you want at least 2. Give me a hint what you want. So we first have our first input texture. So let's go and also make that an export var. This should really all be in a little helper file. It shouldn't all be in main, but hey, I'm just starting somewhere, right? Draw albedo picture, and that's going to be a normal texture 2D. Okay, and I believe that this is an array. No, that's the rect, and then we have a source texture. Oh, hold on. I actually need to do the multi one, even though we don't have it yet. We're going to change to that once we have the other target. So we're going to first start with the rects, and then so we're going to define a rect here. We'll define that in a minute. Okay, so var rect rect2 is okay. So that should become actually, I think that should be an export variable as well. So this is going to be I want to go and rename that to texture size because we're going to have multiple size things. So that's going to be texture size. That's going to be texture size. That's good now. And here we're going to do an export var, and we're going to call that draw size vector 2. We're going to do that in pixels. We're going to go and scale that in a minute. So let's say that we're going to do that as 10 by 10. Okay, so var 2 is that divided by texture size. And I think we might need to convert that to 2 first, just to be safe. Then this is going to be UV minus D size times 2 and D size. That should, I think, end up just a little rectangle where we're drawing. Cool. All right, so now in blit rect, we have that. We're going to do color map, and then we need to set the material. Okay, so here we're going to say color 1, 1, 1. That's just our modulation color. Mid map is 0, and here we get our draw material. There we go. All right, in theory, that should mean that when we now draw, we should be executing these things as we move our mouse. Let's see if that works. Oh, we need to set up a material. So now on our main, we can now see that we have a texture size, we have a draw size. First, I want to put up a material texture. So I had some textures that I got here. So I want to do, yeah, let's do my metal. Oops, metal texture just for now. And then what we want to do is draw material. We're going to go and create a new blit material. Oh, that is, no, I actually need to make this a shader material. So we're actually going to redefine this as that we're going to take in any material. And it's going to error out if it's not the right type of material, but that's fine. And that should allow us to create a shader material here. And we're going to create a new shader here, and we're going to call that draw shader. Boom. Now that defaults to spatial, which is wrong. But let's have a look at what Colin writes here as a sample. So that needs to be texture blitz. There we go. And that has just got a blit function. There we go. Boom. Okay. So we now want just random mode mix for now. That should probably be okay. And we want a texture source, which should be set to our first texture, to our little, that one. Okay. Valid type hint. Oh, hint blitz source 0. Ah, okay, that's still outdated. All right, so we have our blitz source 0. Perfect. Var. We're just gonna start. Oh, not var. Vec4 color is texture. Source texture. And this is actually going to be, so we're going to do a vec2 here. I'm going to call that screen UV. Frag port XY. Now that might be in the actual origin thing, but we'll see quickly enough if that works or not. So that should give us our source texture. And for now, just for testing, I'm just going to output that as this. So we're going to draw a square, which is not really what I want. But for now, we're just going to assign that as the output and just do that the way that it is. Okay, it doesn't like color as an output. What is the output that it does want then? So our info here is outdated. Well, then we're going to go and have a look at this is our default thing. No, that's our blit itself. No, there should be like a default thing. So we got frag coordinate, UV mode. Oh, of course, color 0. I should have known that. Actually, I'm going to call this, just to make it clear, albedo texture. Albedo, and let's call that albedo color, just to make it clear that that is what we're doing here. Okay, is it now happy with what we're doing here? Yeah, that's all old. Cool. Sometimes the fact that it compiles on the fly and gives you too quick feedback is a little bit annoying, but it is what it is. Okay, so in theory, this should now do something. No, it shouldn't, because we're missing something probably. No, we're doing that. We're doing that. Raw material. Okay. So one thing that I first want to try, just in case we're doing something wrong here. Let's just see if that's, if we're actually drawing something. No. Is it going somewhere else? No, it's not. All right. One thing that I probably want to do as well is let's go and put a texture rect in here. There we go. And no, that is fit width. So that's going to go scale. I think I'm going to do it like this. So now copy, paste. So that should be the same object. Let's actually give that resource a name. Say albedo texture. Let's call that drawable albedo texture. There we go. Now if you go over here, and that is exactly the same. That's a nice way to make sure that we have the same thing here. So I just want to show that there. We've got ignore that. We've got scale. No transform. Let's make that a little bit bigger. And let's see if that actually shows up. Okay, so we don't get anything drawn to our texture yet. So our blit is not doing what it's supposed to be doing. So let's go and put a breakpoint there and see if any of this makes sense. All right, what's a rectangle looking like? So that should in theory be right. So the thing that I'm wondering about now is whether this rectangle should be in pixels, which is very likely. And for that, let's go and have a look at how this is actually applied. So in here, oh, come on, don't do this. There we go. Such a weird bug. We got our offset, we got our size. That is directly added here. So that should be in, actually seeing that as GL position, that might actually be in pixel sizes. Well, let's just see if that is, if our conclusion there is right. Should be fairly easy to check. So let's go and just duplicate these two lines. Okay. And in this case, what I want to do is, oh, this should actually have been 0.5. 0.5. But that's, we're just going to do draw size. And here we're going to go and say that can go times texture size. And obviously that needs to be, don't do that. It needs to be converted first. Okay, so now we have a rectangle in pixels. Let's see if that makes a difference. Yes, it does. Haha. I'm drawing. Now you can see that we do have some edge issues here where this is obviously very close to this, but that's something I don't care about because we're just experimenting with this. So let's get rid of these prints because we now know that that works. Now I have a feeling that we're going to have the same problem with our UVs because obviously we need to set that somehow. And that means that first of all, in our shader, we're going to have to add in a new uniform. Back to, call that texture size is back to 2.4, and that's actually going to be a float. So we'll do that like this. Wink. So we're going to go and do that divided by texture size. And let's go and actually output our albedo color. Okay. And with that, we now need to set that on our draw material. So we have our material, that's our ORM material, so that's our original material, that's not what we're after. So we need to do something with our draw material. And here, let's set up our draw material. If draw material, then draw material dot set. cast it for now. Just doing this so that the autocomplete works in our favor. That's shader parameter, and we call that texture size. And we're going to set that to texture size. There we go. And now I actually don't care about this anymore. We're just going to do that. I'm just going to rely on duck typing. Yay! All right, so we're drawing now. Now this is nice and black because our material is nice and black, and I have no idea if this does something that makes sense now, right? Oh, look, that is where we do have something in our texture. That's okay. Yeah, that's the problem, of course. Like I said, we're not allowing for any seams, but we don't care. All right, we obviously need to do something about the size of this. But we're drawing our texture on there. Probably at some point we should do some scale stuff. Yeah, we need to find out a way to make the draw size work properly, or make it settable. Anyway. The next thing that I want to do is, instead of drawing squares, I want to draw circles. But yeah, we can see now that we are painting the texture on there. Oh, it doesn't. Ah, it gets on the back there. That's interesting. Wonder why it's not allowing me to draw on here. Why is it not doing that part of it? So obviously our triangle ray does have some issues in it. I've got a feeling that it might be what you call it? It might be intersecting with whatever the first place is that it finds, instead of getting the closest. You can see that here too. We're probably now drawing on this side of our guy. But hey, it's a start, right? That's all that I care about right now. Obviously, this is not how we want to draw. We want to actually use our screen somehow, or some way of actually drawing our texture that makes sense with the orientation. But hey, this is just a start with how we are drawing, just to prove that this is working as a concept. Right. So let's make it that we draw a circle. That's the next thing that I think we want to do. So the way that we're going to do that is we're going to use our actual UV to get a radius. Now this is going from 0 to 1. So obviously we want to then make that go from so what is that, times 2 minus 1, to make it to go from -1 to +1. And then I want to get that as the length. There we go. Why is that still saying? Oh, because this is shader code Baz, not GDScript. So let's go and do that like this. And of course I can't spell length for the life of me. There we go. Alrighty. So now we have the radius as a length. And with that, we're gonna go and calculate an alpha. And we'll do that with a smooth step. And let's think what we want for that. So now we're getting, the further away from the center we get, the higher the value. So basically anything Below 0.2, we want to have 0. Let's say anything above 0.8. We're doing the radius. Why can I not type? And then obviously that needs to be 1 minus that. Okay, so now we can do here a vec4.rgb veto color.a times alpha. That gives us an alpha output. Let's see if that works. Let's see if we now get circles drawn. Yay! We now have a circle drawn with a nice bit of overlap. And we still have that goes nicely to white. Okay, cool. So now to actually make this something that makes sense and actually makes that a proper texture color, besides the fact that we're obviously not restricting our drawing to whatever shape we're on, because that's the sort of thing that we would want to do here, is that we actually find the seams and create some sort of mask based on the shape that we're drawing on, so that we don't get this overdraw sort of thing. But that's way more than I want to deal with today. Just want to get the principle to work here. So now we want to do similar things with the rest of the textures. So when we look at our metal texture, for instance, that's probably nicer to look over here. So here's our metal texture. We obviously have our, I'm actually using that. I should be using this one, which I'm glad I didn't use, because obviously the color for this thing is white. This is a really bad example. I think I'm going to start with the grass one. So let's go and change that over. And let's go and make our color. Yep, there we go. So now we're going to draw grass on here. Let's see what that looks like. Yay, we have a grassy ploosh. All right, cool. Now we also have a normal map, and we're actually going to use that one. So that's going to be our second channel. But then we also have a roughness and ambient occlusion here. So ORM, I always forget. Here again. Yeah, so we got our occlusion, roughness, and metallic. Now we don't have metallic in here. We do have that in our metal one. So here we get metalness, but this is actually a bad one to use because it's nice and smooth. It's just, yeah, there's not really texturing in there. We can still have some fun with that. So, let us look at what we're going to do with that. So we're going to put those all as inputs, but we're going to combine them in our output. So we're eventually going to end up with 3 outputs. We're going to output our normal, our color map, our normal map, and our ORM texture. And our ORM texture is going to be a combination of ambient occlusion, roughness, and metallic, if we have metallic. And we're just going to put that together. So let's start with creating a normal map on this. And we now need a drawable texture for our normal map. And that one's going to be really interesting because when we start, we're going to have a really bad normal map. And that's going to, because this is just going to be white. And white is not a good color for a normal map. So let's go and start setting this up. So we have our draw albedo. No, we have our albedo texture as, so these are our input textures. No, these are our output textures. And these are our input textures. All right. So here we're now going to get our normal texture as a drawable texture 2D. There we go. We also want to already define our export var draw normal texture is going to be a picture 2D. There we go. Oops. Oh no, we didn't do it here. So let's go and put our normal texture in there. So that's going to be this guy. Boom. Cool. Now, doing a normal texture with alpha is not entirely correct, but we don't care right now. We're just doing it for the simplicity. So drawing our normal is not the way that we should be doing it, what we're about to do here. Let's actually set up our shader first. That's probably a good idea. So uniform, it's going to be our normal texture, and that's going to be blitz source 1. So here we're going to have a vec4. Oops, normal color is texture, normal texture, green UV, go. And then our outputs, don't care about you. Color 1 is going to be normal, but we do not care about that. We're just going to do an alpha mix with that. And again, like I said, not really how we should be doing it, but for today, it's good enough. So we've got all those set up. We've got our normal texture here. So now in our scripts, we're going to go, so we have that one, we have that one. So no, this one is going to be material dot normal texture, and then that is going to be setup texture size X, texture size Y, and this one is going to be RGB 8 without sRGB, so that we're actually outputting that correctly. Now this is going to be interesting to see if that works correctly, because there is some logic about whether it switches our sRGB output, and I'm not quite sure if that works the way that it should. But anyway, so now we actually need to change this to blitz multi, and the rect stays the same, but now here we can actually start building an array. Normal texture. Our color stays the same. Oh, what are we doing? So we've got multi sources that. Then we have extra targets. So yeah, that's right. So here we now, so we're already using albedo texture as our first output. And then our second output is going to be our normal texture. And then if I want a third output, we add that in, and a fourth output, we add it in. Now, that's where it does get interesting, because we're going to have 3 additional inputs for ORM. And that's where we're going to stop using this, and we're going to actually set those as just normal inputs on our thing. Anyway, so we got that, and unfortunately our screen's not big enough. So multi, we have mip-map and then material. So it looks like that is all working correctly. We don't need you two anymore. We now know that that works. So let's go and say, and draw. All right. So let's see if we actually get some normal action now. So as you can see, the normal is screwed up, and that's because our thing is by default white. So we're going to make a helper thing for that in a minute. But this is all working. Now, I don't know if this is not really a good texture to test if we have a good normal map. So we're gonna figure that out in a minute as well. Actually, one thing that we can do in a minute is set the oh, we're actually not doing anything with our what you call it, with our modulate. So let's have a quick look at, where was that code where it was showing all the different inputs. I really should remember where that stuff is. Somewhere here? No. Dang it. I saw it. We scrolled past it a couple of times, and I always forget where it is. Where are the variable definitions? Here we go. Modulate. Cool. So let's add that in just for fun. So in our shader editor, we're going to go and put in modulate here. So what there we go. Is that better? Yeah, that's better. Just for fun. Actually, yeah, let's make this. Is that going to do something? No, that's not going to do anything, is it? I want to make it completely white. Well, we can overblow it. That'll be fun. Let's see if it takes that. If it actually allows us to do that. Yeah. So, and the reason why I wanted to do this is now our color should purely be normal map. Although maybe what I should be really doing, just for testing, is just change the shader so that we we are not doing anything. We're just painting white. The reason I'm doing that is if we see things, yeah, we know that the normal map is working because that output is now coming from the normal map. And I actually want to be able to zoom in a little bit further. So in our camera, I'm going to turn that back to that because even though we can get too close, I really want to get that close. There we go. So yeah, that's our normal map that's doing something. Cool. All right, so we obviously want our normal to be reset properly. So let's put that in. And that's obviously going to be very simple. Let's actually first remove that workaround. All right, so would that be enough to do it that way? Might be. If we just split with the default color. Well, let's see if we can get something to work here. Draw up, blitz, rect. That's going to be rect 2i, vector 2i. So that's going to be 0, and then texture size. So that's a full screen rect. And then we need a source texture. Now, do we have our default textures accessible somehow? I don't know. White. That's just color, but do we have that as a... Get white texture. Okay. Rendering server, get white texture. Let's see how that works. Actually, rendering server.get. Do we have a default normal texture? Let's start with this. So let's just see where that is. Here we go. Because it would be cooler if we actually had that as a normal texture. Oh, but that returns a vid, not an actual texture. Okay. Well, we can make a normal texture, I guess. wonder if it allows me to do this. I don't think it can. I think it'll error out on this, but we're going to try anyway. Now the other one is, what is our default here? I think it's, no, because this is half. So that should be 5, 5. There we go. So that should be our normal. Let's see if we get an error if it actually likes this. No, it doesn't like that at all. Actually, seeing that we are doing that already. Let's also do, oops, VBox. I'm lazy, I know. Oh, that doesn't work. It doesn't get a proper size for that. Okay, whatever. Dang it. I'll do it. I'll do it. So this one. I didn't mean to make that 0. There we go. So we're going to make that our normal texture. Cool. And now here, let's do our same trick as before. We're going to give our resource a name. Drawable normal texture. Oh, there we go. Which means that if I now copy this and I will now paste that here, that has the same link. So we know that we're using the same texture. All right. So yeah, that's nice and black. So it doesn't like that at all, but that's good. That's fine. Sweet. Okay. So we are going to have to give that a proper texture. But we can make a texture for that. So var normal image. Excuse me. Is it an image texture? It might be an image texture. I'm not sure. Create an image. No, we need to actually image. Create no, create empty, no. Create some data, that's what we're going to be using. Okay. That's the one. Okay, so this is going to be an image. Is image dot create from data. Can we please be big again? So this is going to be a small texture, 4 by 4. False image dot. Oh. Really? Right, you were helping me a second ago, and now you don't help me anymore. There we go. We're gonna just make that normal RGB or RGBA. We'll call that RGBA. Okay, so and now we have a data. Okay. Actually, let's do that in a separate func and say get default. Actually, I'll make that make default normal texture. That is going to return a texture 2D. And we are now going to go and pull that from here. And we're going to move this to here. And now we're going to say if our data is a packed byte array. All right. Let's make this really dumb. So this is going to be a 4 by 4, 16 pixel image. So we're going to do in range 16, push back 128, 256, and we actually don't care about the last one, but we're doing RGB8. So with that, we have that we're going to build a 4x4 normal map texture, which means that we also no longer care about that. Thank you very much. Cool. And then we just need to create a and now does that go image to texture, or is it texture to image? No, I think it's texture to texture from image. I think that wasn't here. Or was that? Oh, hold on. No, that's image texture. An image texture is image texture create from image. So we can actually go and do just a return. There we go. And I'm actually happy to say that is an image texture, because image texture is a type of texture tree. Yeah, it's a type of texture tree. I remember now. And that's now our normal. Ta-da! Okay, let's see if that actually does what I wanted to do. Now we created. No, it didn't. It makes it nice and white. Why is that so? 25. We have 16 of that. Create as data 4x4. Really? So that should blit to the entire thing. And it should then use this as input. And then just go from there. And it should just use our normal drawable texture to output. Just want to test. Even does remotely something that I want it to do. Nope. All right, so. Why are you not working, you bastard? Why is that not working? Just want to see if it applies to modulate. Is it even running that whole thing? No. I think that my thing is not working here. I don't think that needs to be like that. I think that's normal. So is my normal image creation here not working? 9GB8, that should be fine. Image section, oh, that's pretty bad that it doesn't sRGB conversion, because this is do we have a way to prevent that? I hope not, because it should be a normal map. Let's see what it does there. Okay, why are you not working? I'm just doing that just so that we can step through this and see if we actually get this. Step over. What? Does that mean that we can't see what we're doing here? Texture, objects. Why can I not see the contents of that texture? That sucks. So yeah, we have an image texture there, but we can't inspect it. I would like to inspect it and see if it actually is an image, because that's the only thing I can think of, is that that image isn't what we're expecting it to be. Now, that said, you know what? 256. 256. Let's just make it return white. Why not? And we'll just, you know, I don't know why it's not working, but oh no, because we didn't see it actually doing anything, did we? Actually, let's undo this. Let's go back to this, because with the modulate, it didn't do anything either. So let's assume that we're creating our image correctly, and that's a problem in the way that we are calling blitrect. Maybe we're doing it too early? I don't think so. So we're setting it up, that's fine. Let's remove this. Well, one thing that we could do is probably just create a material for this and seeing if we can control it. Yeah, because that was just a full rect for the full size. Why would that not work? Well, so we're just going to go and use a material to draw this thing, because I just want to see if we can figure out what the heck is going on. So let's here go and do a that should have been used by default, but let's just do this. Actually, let's go and do. Huh? Oh, that's the draw material. That's material. There you go. Let's just do blit material here and see what happens. So mix, that's fine. Okay, what if we do that? Maybe my material is wrong. Nope, it isn't. Okay, so now let's choose a shader material and new shader, and we call it test. There we go. And that's going to be texture blitz. Render mode is blend mix. Go, and then it's going to be blitz. We don't care about the rest. And let's just say color 0 is vec for 0505 1 1. Okay. Let's run that, see if it actually does something. That works. Huh. Huh. create new folder. Okay, materials. We're gonna go and rename this normal 2D shader. There we go. Boink. All right, then with that, we want to go and save this as normal blitz material. Okay. And with that, I'm going to get rid of this test material. Actually going to get rid of this because we really don't care about that anymore. And I'm pretty sure I can actually send through null here without any problem. And normal material. Pretty sure that we can do this. Do that. All right, let's see how that works. Again, I've got no idea why the normal blit doesn't work, but hey, we now have our default normal map correctly set up. Yay! All right. Well, that's cool because then we can also do something similar like that for our default ORM map, which is quite handy because I think that that shouldn't be white as well. So let's go and have some fun with that, shall we? All right. So yeah, I still don't know why the normal blit didn't work. I'm guessing that that has to do with either the inputs that we had or something like that. I'm actually pretty sure that the way that I created that image there was probably a mistake in there. But whatever. Populates with default data. Our albedo is already white. Okay. So let's go and then create our ORM material. Here, create a new drawable texture. Let's already give this a name. It's drawable ORM texture. So we know what it is. That means we can also go and do ORM texture to go. Now means I can go here, I can go here, I can say copy, I can say paste, and I want this to be a little bit lower. Okay, so now we're showing all three textures in our side, so we're going to keep an eye on them. Cool. Bar ORM texture, drawable texture 2D. Oh, need to grab it. I'm pretty sure that that is again also RGB A8 because we don't do sRGB conversions on that. And then here, the ORM texture. Okay, there we go. So with that, we can now add that to our outputs. Normal texture. And there we have our ORM texture. However, because we need specific inputs for those, we're going to do that as material inputs. So we're going to change that over a little bit. So in this case, we're actually going to go to our draw shader. So outputs albedo. Outputs normal. Outputs ORM. Okay. So we're going to do a uniform sampler 2D. And let's say that's going to be our ambient occlusion texture. I don't actually know what sort of... So would that normally be black or white? That's a good one. Let's just say that that's a default white. Now it's going to be interesting to see whether that actually does some sRGB conversion on that one. But for now, it is what it is. Uniform sampler 2D. Oops. Uniform sampler 2D. Roughness texture. We want that to be white because we want full roughness to begin with. Sampler 2D. Metallic texture. And default. And this is going to be black. So with this, if we set up as no textures, we should be getting those outputs. So let's grab the values and say, in this case, we want floats for that. AO is texture, AO, texture, come out screen, UV.R. And we want roughness. And we want metallic. I'm pretty sure I forgot an L in there, but whatever. Yes. And then with that, we should be able to do a color 2 is VAC 4, and that is going to be AO roughness metallic. I hope ORM also denotes the order, and then let's just output an alpha there. I don't think the alpha is used in this case. All right, so now if we run, we haven't set up any textures. That's nice and white. So when we draw here, we should be seeing, well, I guess yellow is good because that means full red and full green and no blue. Now, again, this is not really a helpful texture to really see that working, but in theory, we should now be able to go over here and we should be able to get into our shader parameters, and that's where we have these. So normally I would also add them here and then do a setter to set them on those, but we are going for cheap and simple. So let's, in our grass, say we want our ambient occlusion. We want our roughness, and we don't have a metallic, so that is fine. So if we do now this, oops, and we draw, well, obviously that's really hard to figure out whether that makes sense, but we're drawing to all three textures at the same time. So everything is nicely being copied in unison. And all that we need now is some way to switch between the different textures and, you know, swap in a different set of textures and see if that does. Now, I'm not going to make the whole swap logic, but I am going to have a look and see if I can find a different texture that might help us do something more fun. So excuse me while I have a look. What would be a nice one that actually... I wish there was something that... I'm just right now, I'm looking at CG, well, ambient CG has been renamed. I forgot about that. We could do something like this. This is actually a pretty cool texture to play around with. Something like that would actually also be nice, probably. Hello. Oh. Yep, we got that again. Because here we have we actually have a texture that we can use. We have some pitting in there. So this should be doing something with the normal map. We also have shininess in there, so we should see our metallic working. So let's go and grab that. And with that, let's go and grab from our downloads this one. Let's do an extract all. We no longer need the zip. Okay, let that load in. All right, so with that, we should have a new metal. So our color needs to go there. Our metalness needs to go there. Normal needs to go there. And we have a roughness. And we don't have an AO here. So let's go and clear that out. Okay. Let's see what that does. Now, I think we need to obviously make that a better default, but and you know that eventually what you would do with something like this is obviously have some sort of material selection, and then based on the material selection, fill all these slots, and then we could draw different parts of our plushie. But yeah, we have made a really simple texture painter. Yeah, that is pretty cool. I am definitely quite happy with that result. So yeah, obviously there's a lot of things to improve here. Obviously we need a better default for our ORM texture because it's now just put to white, so full roughness and full metallic. It's a canvas. We would need to have a way to select different materials. We would have to have a way to actually save this so that you can you can use this as your actual ORM material. You need something to have different brushes. So one of the things that you could do is add another texture to this as an input texture, which is a brush texture. So that instead of our little, and that might actually be a nice one just to add in just for fun. All right, let's have a look if we have free brush textures. That's weird. Let's have a look at that. No, that's not what I'm after. I wonder if Kenny has that. Go away, you pop up. All right, let's have a look at. Would it be in 2D pixels? You do like a brush. Maybe UI. No pixel textures. No. Well, it's kind of like a pattern sort of thing that I wanted to do. Where could we find a good one there? Because the brushes that I see are a little overdone for what I want to do. Plus, I want to have nice square brushes. Because the idea with the brush, just to give an idea, this is just something I just Googled. So the idea with the brush is that you have these little textures, right? Which are just black and white textures. And instead of doing our circle, crazy phone. instead of drawing our circle with just our radius, we just sample with our UV, we just sample one of these brushes. And then we use that as the alpha when we're drawing. And that means that we don't have a nice circle with a nice edge. We actually have, a bit of noise and stuff in our brush, which is a really cool way to do brush logic in here. But I can't really find a nice pack for that, which is suitable for what we're doing over here. I guess we could make one in Krita or something, but I think that I am going to keep this here as, okay, here's a little sample. We have a whole stream how we build it. Everything as far as drawable textures is concerned works really well, so I'm very happy about that. Little weirdness around, what I tried with setting the default values on the normal map. Not quite sure why that's the case. But that was a bit weird. So yeah, I'm not quite sure what was going on there. That was something where I'm sort of going, that's strange. I don't know if I did something wrong or if it was something else. However, this all is working. And yeah, it's a start, right? And from here, it is a matter of, yeah, we're now having our ORM. So that's what happens where you have a purple ORM texture, which is kind of good. So yeah, one thing that, this has been discussed on the rendering meetings, and we went for not doing it. But one of the things that I would really like actually is to have properties on the drawable texture that lets me set up the size and the default format, so that instead of having to call setup, that is just done automatically by the settings here. So that is something that I would personally change, but I know that was not part of the original design, and it was a little bit principled on the choices there. But yeah, that's personally something that I would do. It also means that our default texture here would just be white. I would probably want to have a default color that we could set in setup, so that it's not always white. I can actually decide, okay, make it black, make it white, make it normal, the normal color. So 05051. For ORM 01010 full AO, full roughness, 0 metallic. So those are sort of like the things, right? Where there's a bit of a way up of everything that we could do there. Anyway, I'm going to put this project somewhere. I'll upload it later, and I'll put the link in the description later on today. This is just a toy. Maybe someone will find this useful as a starting point to create an actual texture painting application. There is plenty to need to be fixed. Like I said, we would need to have some sort of edge detection on the part of the object that we're drawing on, so that it doesn't go over to other parts. There seems to have been a problem with the side that we're intersecting with. So I wonder if the triangle intersect logic is just finding the first triangle that it hits, or if it's actually something else. Now, on that subject, we could do our own triangle intersection logic and find the closest one. But on GGScript, that would probably be too slow. Yeah, plenty of opportunity for improvement there. But I'm pretty happy where we ended up. So I'm going to leave it there, guys. Thank you all for watching. I hope you learned something. All in all, the drawable texture thing gets a thumbs up for me. I really like what it does. My remarks are minor. But yeah, it's working really well. And it's the fact that I was this quick to build a full ORM material-based texture painter. And it just works with drawable textures. Yeah, this is a good base. It does what it needs to do. I'm happy. So with that, I'll leave everybody. And yeah, again, thank you for watching, and I'll catch you guys next time.